Welcome back to Unity Tips and Tricks. In this video we're going to take a look at how to procedurally create geometry in Unity. So we're going to start with the simplest possible geometry, a basic quad. And I've got the script already written here in the interest of time. Let's go through it. To start off with, the script is going to be something we can use out of the game object menu. So we'll come back to the script, but if you look at the game object menu, come into create other, it will show up as custom plane. And go ahead and show you what that does. A couple important things. One, it actually makes a new game object here for you called simple plane. And the other really important thing is that if you don't want this to just be a runtime piece of geometry, it actually saves the asset here in the project panel so that you can reuse it later. So for instance, I could drag out another one. Now we got two. Let's jump in and take a look at the code. Okay, called this procedural geometry. We're just going to use some static methods in here, but it does have to be in the editor folder, and we are using the Unity editor. So to start off with, we give our method here we're calling create plane, we give it an attribute that allows it to show up in that menu. And it's called menu item, and then you can have the whole directory structure in here. You saw first we went into game object, create other, custom plane showed up. So every piece of geometry is at a minimum composed of a list of vertices and a list of triangles. Now the vertices are just points in space, which isn't really enough information to tell you how they come together to form the geometry, but that's what the triangle list is here for, and it's made up of consecutive groups of 3 numbers where each of these numbers is an index into the vertex array. So we have 0, 1, 2. That would refer to vertex 0, 1, and then 2, which if you look at the diagram I have here would come out like this in a clockwise fashion. Whereas 2, 1, 3 would represent the other half of this quad, the other triangle. And they're both wound going clockwise. The winding is important because it's used to determine which direction the triangle faces. Because Unity uses the left-handed coordinate system, a clockwise winding will cause the triangle to face out of the screen and toward you. Whereas if we ordered this a little bit different so that it was counterclockwise, say it went 0, 2, 1, that would cause this triangle to face away from you and into the screen. If you guys want to know more about this left and right-handed business, just go ahead and do a Google search, and I'm sure there's some good websites out there to break it down for you. So a list of vertices and a list of triangles together will get you some geometry. But what if you wanted to do something crazy like apply a texture to your geometry? Well, neither of those things are really going to help you out here. We need more information, and that's where these texture coordinates, or these this list of UVs here, comes into play. Now a UV or a texture coordinate it's a value that identifies a position in a texture. To show you more what I mean, let's look at this image right here. This also corresponds to the way Unity does it, where everything's kind of in the range of 0 to 1, and the bottom left corner would represent a UV of 0, 0. Now in this image it shows ST, which is kind of another common naming convention for texture coordinates, but U would be S, T would be V, and they're kind of the same thing. So U0, V0 would be bottom left, whereas U1, V1 would be top right. If we had some geometry here, we might want to use these coordinates here to determine how this texture should be draped over it. So the way those UV coordinates get applied to our geometry is that they're indexed the same way as the vertices, which in this case means that UV0 corresponds to vertex 0. It also means that you're going to need to have the same number of UVs as you have verts. So we have 4 of each, where each index corresponds to the other index. That means that UV0 here with texture coordinates of 0, 1 is going to be applied at the location where vertex 0 is at right here. So going back to our picture, 0, 1 is going to be the top left of our texture, and we happen to be applying it to the top left of our quad because we want it to match. And we do the same with the rest of the UV coordinates so that they all kind of match this geometry in the same way that the texture is laid out. So those are the basic ingredients of a mesh. One thing we kind of skipped over were normals, which tell you about the direction of a vertex. And that's used for lighting, but that can be automatically calculated, so we do that right here. And once we have our mesh finished, we can go ahead and create a new game object. And to render a mesh, we actually have to give it to a component that holds our mesh information, called a mesh filter. And we need something to render it, so we give it a mesh renderer too. That will create our object inside of the scene, which is good if you just want to do some procedural geometry. But if you wanted to reuse this as an asset, we actually have to take another step and save it. And we do this using an asset database create asset with our mesh, and we give it the name. And one important thing here is that you need to give it the .asset extension or it won't work correctly. So let's go through the process one more time. Got nothing down here in the assets. We're going to create a fresh one here. Go to custom plane. You can see that we have a reusable plane down here, one in the scene, but there's no texture on it, so let's go ahead and test that. Using that same image that I showed you for the texture coordinates before, I'll drag that on there so we can verify it, and that looks pretty much like what I expected. We have the texture mapped on there using the coordinates the way we specified. So that's it for this video. See you guys next time.